So welcome everybody. Thanks for joining me today. I'm going to share 30 years of experience with you in 45 minutes. This is going to be great. But I do have lots of great stories, lots of really innovative stuff that I am excited to share with you. And they all kind of wrap around this nice topic of Industry 4.0. So let's get started and talk a little bit about Industry 4.0. All right. Most of you have probably heard of a little bit of this Industry 4.0. What does it mean? And really, it's kind of an umbrella term, and it means that industry, as we know, is changing, and they're doing something that we call a digital transformation. And so basically, almost 90% of industrial companies are investing in this digital factory, just to certain different levels, some at a high level, fully digital, and some to just dabbling in a few of the technologies that might be available now in this kind of digital transformation. So with that, us as health and safety professionals need to be aware of what's happening around us, right? And a lot of the times in past history, this is what we would call a disruptive technology. So you can imagine you're driving around with your horse and buggy, and there's this guy that kind of comes in to say that we're going to have production of vehicles and they're going to have no horse attached to them. So this was disruptive. People didn't adopt it overnight, but basically it was a rapid transition from an old technology to new technology. And I bring this up because no matter if you think of yourself as Industry 4.0 leader or doing something in that space, it's going to happen. It's going to happen around you and is happening around you in all different aspects. So that was the horse and buggy going to a vehicle, the idea of steam engine, now going from sailing to steam. So this has happened over and over and over. And I think in the automotive, we're seeing going from combustion engines, going to electric cars. And so you're going to be seeing this on all fronts of our lives, this idea of new innovation and new technology. So my challenge today to you is don't just live in your bubble. Okay, live in your bubble from a COVID standpoint. Okay, that's a good bubble. But don't live in your bubble in terms of your awareness. What's happening out there? What technologies are happening, and what are other industries doing, one that you don't really work in, that are really pushing some of this new technology. So I'm sure all of you are sitting there with some sort of phone there. You know, I remember saying that I'm never giving up my camera because my camera was beautiful, and now I don't think I've taken my camera out, and I use my phone to take all my pictures. So it happens to us because the technology develops around us, and we find that the technology is good and that we can then apply it to things that we would normally have done a different way. So don't be frightened, keep an open mind, and let's see what some of this new technology is that's coming. So what does Industry 4.0 even mean? And what kind of technology can we take advantage of in the health and safety world? All right, so I can't even touch on all these topics today because if anyone knows me, I can talk a lot. And so 45 minutes means I'm going to have to talk fast. So I apologize. I am a fast talker, but I will tell you some really great stories. So Industry 4.0 really means that idea of new technology coming into our industries so that we can reap those benefits of improved productivity, improved quality, and I'm going to suggest to you today, improved safety. Okay, so let's talk about some of these new technologies that are on the forefront. The idea here is that we all instrumentally want to make jobs better. We want to make them safer. We want to make them cognitively less demanding. We want to make sure that that we support our workers. You know, at Ford, we used to say that our workers were our greatest asset. And more, I think companies are realizing that you need that amazing machine of the human to be able to do these jobs that we need them done. But the advantage of having a human is that they are so flexible, and then the disadvantage of having it is that flexibility means that they can often stretch themselves beyond limits, and those limits then result in discomfort and injury to our workers. So we need to be thinking now, what technology might be out there? Let's learn from each other on what technology we can bring in then or explore so that we can help those workers. So the first one I want to talk about is exoskeletons. This is basically support of the muscles. So basically the premise behind an exoskeleton, whether it be passive or active, is that it is going to give the muscles an extra boost support. Okay, I just wanted to let you know, in my venture of an exploration of exoskeletons, we messed up really bad in the beginning. So you'll see here on the left that there is a tool attached to their waist. And so we thought that having the power tool attached to the worker, just like, you know, attaching inside a backpack, would be a great support for the worker, and they wouldn't have to support the power tool overhead. Just so you know, that didn't work. So what happened is we then put a moment onto that person, and as they moved out of horizontal and out of vertical, basically, that moment then was on their spine, and we actually added more stress to the worker than helping them with reduced stress. So we went back to the drawing board. We worked with experts in the field. So there was a lot of work happening in this area with injured workers or disabled. And so they had a lot of experience in the exoskeleton. So kind of leveraging that technology, opening our minds to there may be something out there. We worked with a few of the exoskeleton companies, and they're continuing to improve, but basically came up with a design then that supports the worker. In this case, we were after overhead work. Now, the ergonomist in you and the health and safety professional in you was saying, well, Allison, why didn't you fix the job? Believe me, I was there for 30 years. I tried my darndest to fix these jobs. It is not easy to turn a car upside down. It is not easy to figure out how to put mufflers underneath the car when, you know, and so you basically are stuck with these jobs that are overhead work. Now, we did do great jobs. We did minimize the amount. We rotated. We, you know, put articulating arms where we could. So we had done to what we felt was the extent of what we could do on an engineering standpoint. And now we wanted to improve the capacity of the workers and give them a helping hand, because these jobs still need to get done. So that was where exoskeletons to us was a really great breakthrough, right? This idea that we could then support the muscles and reduce that fatigue. And so that's where we started with exploring some of those. So I used a lot in the overhead application. We're seeing more and more come to market. There's two types, a passive and an active. We used a passive, meaning basically springs and elastic, but there are some that have motors in them. The Back X and Suit X, I believe, have got some of those. And basically all they're doing is giving support to the muscles so that it helps reduce muscle fatigue. Okay, there's even a lot now that are saying, okay, well, it's not only holding your arms overhead or helping with lift, but even for those who have to have static postures for a long time, something to lean on. So there's a lot that are developing in that area that give you extra support then for these static postures, which were difficult for us and are still causing injuries out there because there's no easy solution. Okay, so I really am just saying there's new technology on the forefront here, and we need to be a little bit open-minded. So I often get, you know, do they work? Well, my suggestion to you is give them a try. They physiologically work, meaning when you support the muscle doesn't have to be activated. and therefore the muscle activity does go down. Now, does that mean they're going to work in every situation? Like I said with my first trial, when you start bending to the floor, when you have a overhead one, you need to look at that. Maybe the application shouldn't be on a job that has on the floor and overhead work. And maybe you do or do not have jobs that are like that. So I'm not saying jump in the pool without understanding what you're jumping into, but I am saying that there are some really cool technology out there that does work in terms of a muscle fatigue. And it's really exciting for us to get involved in health and safety. All right, so now we've helped the muscles a little bit. So that's really cool. But we still have some jobs that are really not the best, right? We have new products coming in. This is a side airbag being installed. Customers seem to like their console in the middle of the vehicle, and we haven't been able to convince them otherwise. So we still have some jobs that need a little help. So for this, I'm suggesting that maybe we go and look in the world of collaborative robots. This is a new and upcoming. So there's going to be a little bit of music here, but I can talk over it, don't you worry. The point here is this is Digit, and Digit just doesn't have muscles, but he can do all the same actions, right? Now, he doesn't have very good visibility. So, you know, a human is always better for the visual acuity and things like that. And he is coming a long way, don't you worry, the vision is there. But as you can see in the little video, they don't fatigue. And that is something that might be really helpful for us for some of these complex tasks, heavy tasks that we would like a helping hand out in the on the plant floor. So if any of you are feeling that you haven't had enough activity, as we were just talking there, standing, you can try and compete here against Digit. I have a feeling Digit might actually win. And there you go. And he's out to the end. All right. So the lesson here is, again, there's some really cool technology that are being developed, and they're not necessarily being developed for your industry or your application. But what we can do is we can take this technology and say, how can I help this in my technology? So for a fact, you know, Digit is actually being designed in order to meet the market of delivering packages remotely to your doorstep. So, and that last kind of step of that. So I think there are a lot of technologies that we can then borrow and say, how can that really help us in the workplace to make it a safer place? So here's kind of a KUKA robot, I believe, that is a universal robot that is assisting then loading. So this had some reaches and you know, some bending in the job that wasn't able to be fixed easily with a redesign. And so now we have a helping hand here of a collaborative robot. Many of you should say, oh, is a collaborative robot safe? It's really, it's a shame actually that we call it a robot, because we always have this image that it has to be locked in a gate and fenced in. But these collaborative robots and the technology that's in them is very safe, but I am going to encourage you, do your own risk assessment, right? They are controlled speed. They have great monitoring of force so that when it touches anything, it has immediate stops. But you shouldn't trust me. You should just learn from me that there's really cool technology out there, and then work with the suppliers, work with companies, and find the right fit for you, and make sure that that the risk assessment is done to your standards. But I was very, very impressed. You can imagine there's lots of challenges out there, and these the technology is so advanced these days that I believe that collaborative robots are going to make their way in to industry and really help make some of those really tough jobs that much easier. Then there's this whole other industry of autonomous vehicles. Okay, I am not sure I'm ready to be sleeping like that in my car, but the idea is really phenomenal, right? And this is what you have to think. If they can do that, what can we do to make our workplaces safer? So I know at Ford, we had a lot of PMHV concerns, right? And so the technology that they're investing millions in is available. And so we know that the cars can talk to each other just like that, keep us safer on the roads. That technology can come into our factories. So there are now autonomous forklifts, right? So that they don't have pedestrian issues. And there's also the long durations of driving that. So there's things there that we have traditionally in the health and safety role have concerns with. And so I'm just saying that there are other industries that have really explored and made available some of this technology that we can do. Just saw a great presentation. They are mining, and they had a lot of serious injuries in the mining industry, and they are mining now using autonomous mining equipment from a control center. And so far, their technology and the advancements of it are really proving very positive. So again, just opening our minds to maybe there's something out there that we can bring into our factories and our workplaces. Even if we don't take the whole autonomous vehicle, we can take things that the autonomous vehicle has developed. So this detection system within our safety vests, a beacon that tells the fork truck driver, not actually the driver, but tells actually the fork truck where we are. So this then applies brakes just like in your car when it gives you collision detection. We can have collision detection brought in to our factories and make it a safer place. And this is not, I'm going to decline that annotation request. This is, some of the technologies that's readily available that we will be able to bring in and make our workplaces safer then. So again, it's that open mind to new technology that I really want to get going. Okay, I've said it a few times now. Are you getting it? There's a lot going on with this Industry 4.0. And because of that, I really see changes. Now, I do think of myself as rather innovative and open to change, but I do want you to know that it was really kind of forced on me. I didn't necessarily jump in the pool without a little push. So Ford was going through digital transformation. They were designing their vehicles in 3D, and the paper pencil and the prototypes that we used to have were going away. So they would make decisions about the design of the vehicle and the design of the workplace, the assembly plant, in the digital world. And they would do that before we went into production. So here I am running around that plant, talking to workers, making the workplace a safe place as an ergonomist, and the rest of the world were working in the 3D space. So when I then complained that maybe there was some problems in the design of the vehicle, they said, "You're too late to the party. We've been having this design party at least 2 years before it gets into production, and you didn't show up." So my first reaction is, I can't show up. I don't have a worker. I don't even know what the job is going to be. How can I tell you how to design this job when I don't even see a worker lifting a part, right? Are you going to tell me there's a part? Like, where's the part going to be positioned? It's not been designed. So I really struggled with, okay, I want to be innovative. I want to be part of the design team. How am I going to get there? So at that point in my journey, I started exploring with digital human models. And as you can see kind of in this slide, car comes with all the different components. In the digital world, the engineers build that car so that they know how it's going to go together. It's like Lego, really. You get the Lego and then you get the instruction book on how you're going to build it. And that's what's sent to the assembly plant. So in steps ergonomics and says, we want to be part of this instruction manual, and we want to be able to reject things that don't go on properly. So the only way we could do that, because of that digital transformation, is we had to find a replacement for that human in the design process. I didn't mean on the assembly plant. Humans gets to build it. We just need to be part of the design process. And the way to do that is that bring in the digital human model within those design reviews. So in this case, that was really the start of the proactive ergonomics program at Ford. And we would be able to position mannequins then into locations to make decisions about reaches, about hand clearance, and then even about whether or not someone will be able to hold that part in a static posture. So we were able to do some analysis of that. We ended up using motion capture, and this is a concept of motion capture. This technology is used in the movie industry, and so the cost to be able to use the motion capture significantly came down because of the video gaming industry and the movie industry using that. So that's kind of part of these digital transformations, is others are consuming and developing this technology. So being aware of how they're using it can then lean over and bring. I remember watching my son do this amazing video game of, you got it, shooting up stuff, and he could switch rifles and guns in milliseconds. Meanwhile, I was working on simulations, and if my model had to pick up a power tool, put it down, and then pick up a different power tool, it took me at least 10 minutes of simulation time to recreate that. So those ideas of grasping objects, releasing objects, I'm like, we need to figure out how they're doing that in that video game. And sure enough, the web had the answer, and we were able to adapt some grasp and ungrasp technologies into our simulation that then helped us do faster simulations and better simulations to make better decisions. So what is this digital human going to tell me, right? So why go there? So you got to think now, I'm in these design reviews. I'm working with the engineers. We're going to design these assembly plants and the vehicle. We wanted to know what the worker would say. Would they be able to do it? Would they be able to see it? Is this a blind operation? And so this is where the digital human modeling technology has really come a long way. We were able to have eye view on our model, meaning that we could actually see where they were going to be seeing. So we could tell whether or not some of these operations were going to be blind or not, we call them. We could then evaluate how far the reaches were based on where the parts were going on the vehicle. And then not only then when you see how far they are and the weight that's in them, we can then do some calculations of how much compression is on their back and how much torque or how much muscle effort is required on each of their joints, and give us an idea then of the stress that we would be putting on, or congratulating the team when we would design it well so that there would be minimal stress on those joints. So, you know, I'm 20 odd years in using digital human modeling, and we've got lots of experience under belt. I still think that the models are still growing and there's still technology in that. It's like those darn phones, those cell phones, they get better with every version. And that's what's happening with the digital human model. I see us getting more technology in there. I know we're going to have Dr. Potman's going to talk to us about some of these risk assessment tools that are coming out there that I then see being able to be integrated into these digital human model. The model is basically an avenue for the health and safety professional to then just bring some of those kind of advanced tools into our realm, and so that we can use them. So basically here you're saying we're using now the digital human model. We did some follow-up studies. You know, we're in a big corporation. They want to know, okay, you've been doing this now. Is it working? And we were able to, again, a little bit out of date, but basically we were able to see that we saw a 70% decrease in our injury rate. That's impressive, right? But think about it. Instead of waiting until you get the injury, if you got there and when a new part came into the plant, it had already had its ergonomic assessment. Could you reach it? Did you have enough hand clearance? Were you strong enough to put that part on? It really then meant that those risks were reduced before they even got to the plant floor. So we were, I'm happy to tell you that we did spend a lot of, the investment was well worth it. And also it was nimble. If we needed a design change, we could make the change before the metal was cut. In the past, if I was looking for a change because it wasn't going on well and we were having high injuries, then it would be a long process to get all the retooling and all the redesign. So, you know, by this introduction of this proactive, I call this the old process. We used to wait for production or even wait to prototypes. We thought we were pretty good. We'd wait to the prototype vehicles. But now, taking advantage of this digital transformation, utilizing digital human models, we were really able to get these decision-making process in the design phase. And again, just like we saw the introduction of, or the reduction of injuries, we also saw the reduction of how much it costs to fix these problems. So if you make this assumption of around 45,000 to fix a big engineering issue, so I had to, you know, to make a new part, I had to get retooling to address things, I had to move parts, I had to double up labor, all these things. We averaged it at about 45,000 to fix these big issues. We identified in the physical builds back in 2004 over 300 of these types of issues, right? Now, now I even say this is 2011, so sorry, my data is a little bit out there. We had dropped it down significantly, that we caught these issues in the digital world. And now the only ones that had made it through were about 60 of them. Now, you know, some of those I hope to say that they're getting better at as our models get better and as our knowledge gets better. Maybe they are even getting lower than that. But as you can see in this realm, it was a transformation. It was a disruptive transformation to the way I did ergonomics. I used to talk to that operator and make changes based on what I was seeing on the plant floor, to being able to now go up, work 2 to 3 years ahead of time, find these ergonomic issues that we would potentially be having in the workplace and make those changes. The other part that happens here is that you get all this data now. You've got these digital human models, you've got these digital workstations, and you then start to find that other things can happen. Just like my camera doesn't come out of its case very often, you can find that you are looking for engineering fixes here and some safety aspects of, you know, can I see this? I talked a little bit about that vision technology. So here we have, we're trying to find out if this operation and whether or not the operator would be able to see this pin safely and be able to deck the transmission onto the engine. So they are what we call immersed in technology, and they are looking then at testing out processes. And my favorite part was I used to say, well, let's pull in, because, you know, I really am someone who would like to be out on the plant floor talking to that operator. So I actually was able to pull the transmission decking operator off the line, bring them into my lab, suit them up, and say, okay, this is the transmission you're going to be seeing in 2 years, but they're changing how it aligns. Could you do this? Is this similar enough? Do you see it? And they were able to then give us feedback well before it's there. And then one of my favorite was going back when we launched that vehicle and asking the lady who was decking transmission, so how is it? Is it close? And she said, it's close. It really feels the same as when we were playing with it in virtual, you know, 2 years ago. So that's really cool that the technology is that lifelike. And, you know, if any of you are like Star Wars fans, if you watch how they made The Mandalorian, the technology is mind-blowing. So that's your homework for those interested in the virtual reality stuff. So again, I've now got this very rich database. The company has moved in this digital transformation. I believe there are more and more exciting things that we can do, right? I didn't get to do a lot in the augmented reality space, but we were just exploring that, and I know that it is bursting. And one of the things that we were looking at is, sometimes accidents occur because of the human error, but that human error is that maybe they didn't have enough training, they didn't know a process, they didn't know a verification step that had to happen. And so because of that, we can now use some of the digital data and overlay it onto our real world. So that's what augmented reality is. And so I often thought of this for maintenance. We used to have some injuries in maintenance. When we do our accident investigation, it would be, well, this machine doesn't go down very often. So when we were in here and a breakdown, we thought this had to happen before this, and those steps really were critical in knowing. So you'll be able to wear your headset, you'll be able to pull up the instructions, and not only will they just be instructions in words, there'll be instructions, as you can see here up on the thing, that says this part needs to go first and this part needs to go second. I really see it on those really complex things, but then training of new employees on the safe procedures and the right process is also something that they're exploring with a digital or augmented reality. And I know I was just talking to someone else on equipment installation. They were using augmented reality to make sure that they were putting in this very expensive equipment in the right locations and aligning it up then with the digital data, and they could look at the existing. So I can really see this coming out into us. If for any of those doing like safety inspections, you've got your rough building, and from the digital data what you're supposed to have there, and is it in location, and is it in the right location, and you'll be able to do your safety inspections and have that digital data right there in front as you turn your head and look at the different aspects. So I think again, this idea that we are in a point, Industry 4.0 is throwing a lot at us, and we need to be open-minded to make sure that we can utilize this, because there's some pretty darn cool technology out there. So here again, you see the Vive headset, which your kids are probably more familiar with than you, but that tool is like the TV screen right there and a computer generating all the images you need. So in this case, you can do reviews then, and you're in 3D and you're actually walking through this building virtually. So I really see that the transformation is coming as this technology advances. And I say, bring it on. Let's see what we can do. How can we use this to our advantage to design the workplace correctly, and try and even do some of those risk assessments in the virtual world where the risks are minimal because it's not real at that point. So I think there's some opportunities even on that standpoint. And again, there's so much data and so many things that we're getting that, Apple has just introduced, I believe, LiDAR into their iPhones, but there's also motion tracking technology in there. And so I even see us not only in helping to design the workplace, but helping us to be able to do our risk assessments better. So there are some gloves out there that have force sensors and measure the number of repetitions. You can hold your phone up and it can do some ergonomic assessments of the joint angles and things like that. So this idea of artificial intelligence to assist us in our risk assessments, I think, is coming and worthy of our attention. Again, I'm not saying jump in and believe everything, because it is so rapidly being introduced, but by all means, jump in and start playing with it, so that you can find out if it's the right fit for you on there. I'm excited about also wearables. I mean, we're all getting really comfortable with wearing our watches that monitor heart rate and things like that. I think there's going to be some safety equipment that we can put wearables that might really help us with ensuring that our safe processes are working. So heat stress monitoring, what is the ambient temperature and how are you responding to it, each worker, I think is something that is easily there because of that technology. So again, this is rapidly progressing, but I just wanted you to open your mind to that idea that there's really cool technologies from other industries that I think are going to be really disruptive to the way we have been doing our health and safety and ergonomics in the past. So I am going to wrap up there. I think I'm good timing wise. And my message today is there's a lot going on in Industry 4.0. Don't get so busy that you miss out on the new things that are right in front of you. They are right in front of you. There's really a lot of technology out there, and as health and safety professionals, I encourage you to get caught in that YouTube rabbit hole, but also talk, network, and find out some of those new technologies. I think they're going to be really impactful on how we as health and safety professionals can bring in some really safe workplaces in the future. And I'll end there. Thanks, everyone.
Great. Thank you so much, Allison. Now, do we have any questions?
Yes, there are a few. I'm just, I think Melissa's answered most of the lighting ones. And there have been some comments around the continuous movement from Dwayne's presentation. So I think there was a question about, are there mixed reports in terms of evidence base for the effectiveness of exoskeletons? And then someone referred later to a special issue in human factors, but I don't know if you had any comments, Allison.
So I don't seem to be seeing that chat, but so again, the exoskeletons work, but whether they work for your industry, you need to do the specifics, right? So an overhead work exoskeleton reduces the muscle fatigue. However, if you put that overhead work exoskeleton in, and that operator is a maintenance guy and he's lifting over here at one element and then he's reaching over there, it may not be the best application of that. So you do need to remember that you are the health and safety professional, and everything you bring in, you need to bring in your risk assessment type things and look at that. My word of advice is work with the supplier. They are really good at knowing where their product excels. And then if it's really new frontier, which is really exciting, work with universities and colleges. They've got a plethora of students and academia that are very interested to help and investigate these new technologies being introduced into the workplace.
Thanks. There's actually a related question right after that in terms of passive exoskeletons that may reduce muscle activation, but can they increase the compression and shear force on the lumbar spine?
Again, it really goes to what you're doing. There's a lot of research out there right now, and I will say that they reduce fatigue and muscle effort in the things. And if you're in an upright position, like a lot of the overhead work conditions that we did not find that they increased compression, but that makes sense because they're not bending. But yes, if you bend and you have weight on your upper body, you're going to increase compression. So again, think about your application. It is not a one size fits all, but it may be, there may be a very specific one. If you have bending issues, that you get a bending type exoskeleton. So again, you can't run out and grab the technology and throw it at your industry, but you need to be aware that there is really cool technology out there that I think you could explore and find the right fit for your industry and your needs.
Great, thanks. There's a couple other related questions as well about, and it's a parallel with the criticisms behind traditional back belts, where there was a potential for a false sense of security or loss of strength through continued use, which may lead to injuries during instances when the person is not using the belt. So has this been investigated or reviewed with exoskeleton use? I guess the injuries without it, and
Sure.
then also what about loss of muscle tone and
So,
potential stress effects?
so I would say I personally don't believe it. There is a lot of research out there. There's quite a bit coming out, so you can read it yourself. But again, we haven't had them in use for many, many years. But in terms of me wearing it, it's like saying if I was at the gym and I was lifting 50 pounds, and now I'm at the gym and I'm only lifting 10 pounds, am I gonna have muscle loss? Probably not, right? I'm still using the muscles, so I'm still activating my muscles. I may not have that, you know, high weight, but we as health and safety professionals and ergonomists are saying, yeah, well, we don't actually want you to have that high weight. That's why we've introduced the exoskeleton. So I can tell you that in wearing it, your muscles are still active. It's not like atrophy from not using your muscles. You're just not using the same effort when you're using the exoskeleton. But there is a lot of research coming out on that. So you know, do your background, and again, be careful on your application.
Right, because yeah, a related question was not just loss of muscle tone, but around stress effects on the joints that can't move or stretch maybe as they otherwise would have been able to, I think.
So if you're concerned about that, you should be concerned about wearing a backpack, because they basically feel like that. Now, that's the ones that I've been using, is that they are, you know, we wear a lot of safety equipment too, right? And some of it has impacts, like our helmet has extra weight on the head, and I'm sure that's putting stress on necks, right? So there's no doubt you are adding weight, but in this whole development and in the progressions, we're not adding like 150 pounds. It is not the Iron Man suit from the movies, right? The designs are trying to understand how humans move, not affecting that joint mobility, or at least making it as least intrusive as possible. And I've even found that working with my exoskeleton suppliers, if I've got suggestions and we saw rubbing or anything, we've always then, that's the great thing about these new technologies. We adjusted and then continued on from that. So I would encourage you, these are great questions. Don't stop asking these questions, but don't let those concerns stop you from investigating it.
Great, thanks. I think the last question is more around, have you reviewed any of the tech tools / apps that are out there now in terms of wearables or video technology? I guess if you're offering any consumer.
Yes, but they didn't give me enough time to tell you all that. There's a ton of apps out there, technology out there. And again, I'm going to say it depends what you really want to do. You know, I complained that, you know, I went into academia and I thought this is going to be cool, but every darn year I keep adding more content to my classes because there's all these new texts that we review and bring in. So I think actually I'm going to kind of leave that one even to our next speaker, Dr. Potvin, is looking at some of that, those new tools and things like that. And I'm going to say that, you know, maybe we're going to have another webinar on all those wearables, because there's a lot out there and some really cool stuff.
Great, thanks.